here a variable m. We're not sure. I know what it is. You don't get to know what it is, right? And what this command is going to do is, first of all, this rand norm m2016 is telling me take 16 observations from a normal distribution that has a mean of m, whatever variable I stored in here for m, and a standard deviation of 20, okay? And it's going to find the mean of those 16 numbers. So that's what this command is going to do. Yeah, you know what I'm saying? These are 16 numbers taken from a normal distribution. That's the mean, whatever this number is that I put in, that I stored in the calculator already. Standard deviation 20. Yeah. So it's those 16, and then we'll find the mean of those 16. You're going to have to figure out what n is based on whatever this calculation spits out. I'm going to tell you that's not n. I mean, it should be fairly close, right? The idea is, how close? Maybe, I don't know. Check it out. So your goal right now, okay? So your task, and I'll set up a timer for you. It'll take about 6 or so minutes. Try to figure out, based on this information, what the actual mean of this normal distribution is, right? Okay, so what were some ideas that you guys came up with? What did you think? Some ideas, some ways that you guys thought of calculating this. Didn't work. The inverse normal. Try the inverse normal, okay. It's what you're saying, the reverse, right? Where you get a value from the table and then get a z-score from that value on the inner part of the table, right? Okay. You have the standard deviation. So you had, this is unknown. This is 20. You had a sample mean of 216.73. So the standard deviation of the sample, is going to be 20 divided by root 16, right? Because we're assuming that it's coming from a normal population, so our conditions are met. So 20 divided by 4 is 5. All right. Okay. So then. Okay, so if that is the standard deviation of our sample, then I think that I could make an estimate where this is m plus 5, m minus 5. So I think that our true mean is somewhere in this interval, right? We've created an interval. That interval is x bar plus or minus 20 over root 16. Yeah, that's one standard deviation. So maybe that's not good enough, right? So we could expand our interval, right? We could call it so okay. What percentage of our data is in this interval? 68%. So let's represent 68% error, right? This is a 68%. This gives us a 68% margin of error. Okay. So if I was to do this, this gives me 95%, right? So essentially, this interval captures 95% of our possible values of n, right? Of our possible. So you could say even that you're 95% confident that the true mean is in this interval right here, right? And that's really what we're getting into when we're talking about confidence intervals, right? We're going to create an interval at a level of confidence that actually captures that true mean. The true mean, so we can say that we're 95% confident that the true mean actually doesn't exist within this particular interval. You can't say that, yeah, so, and we'll talk about the different ways that you can say that, and the different ways that you can't say it. But the way that I said it is pretty much clear. So there's two ways. You can say you're 95% confident that the true mean is within this interval. That's really the best way to say it. Or you could say you're 95% confident that the true mean is calculated, something like that. All right? Okay, so let's talk about now what is a point estimator in a point estimate. Okay. So our value x bar turned out to be a point estimator. All right. So and the definition is a point estimator. It's not a proper noun, but I'm going to just go ahead and capitalize it. So a point estimator. All right. It's a statistic that provides an estimate of the population parameter. All right, so it'll take on values such as x bar and p hat for our intents and purposes for this class. All right, so we're ready to get an example in. Here we go. The eraser works too hard. All right, let's check it out. In each of the following settings, we're going to determine the point estimator we would use and calculate the value of the point estimate. So the makers of a new golf ball, they want to estimate the median distance the new balls will travel when hit by a mechanical driver. They're going to select a random sample of 10 balls and measure the distance each ball travels after being hit by a mechanical driver. So here are our distances in yards. What do they want to do? They want to estimate the median distance. So what do we need to do? Find the median. So what's our sample median? Are these in order? Dang it, they're not. Whoops. All right, so we got two. We're gonna have to put them in order. 282. 284 times 2, twice I should say. That's 290. All right. Now we can do it. All right. So. 285 in the middle. So this is our middle. So 285. Because 285 times 2 divided by 2 is 285. So our median is 285. Okay, so that's going to be our point estimate. So here's our point estimator. And we kind of went over how we calculated it. Okay, so B. Hey, the golf ball manufacturer would like to investigate the variability of the distance traveled by the golf balls by estimating the interquartile range. Yeah, see, it's good that we go back to these things because it's very, very important to know how to calculate your interquartile range. We're going to go quartile 3 minus quartile 1 equals IQR. What was it?
It's 287 minus 284. 284, which is 3.
Oh, well, careful.
No, that's for outliers.
1.5 IQR is for outliers.
IQR is just 3.
IQR is just quartile 3 minus quartile 1. So the 1.5 IQR you're going to use, right? So if you have a value that is below 1.5 IQR, right? Or above, it's an outlier, right? But we're just calculating the interquartile. What is it? 3. Oh, right. So there's our other point estimator that we would use. How about the math department? They want to know the proportion of students who own a graphing calculator. So they're going to take a random sample of 100 students and find that 28 own a graphing calculator. Huh. What is 28? Yes. It's p hat equal to 28 out of 100, right? Which is, so that's our point estimator for that. Yay, point estimators. Ooh, yards. Ooh, yards. Okay.
That's really good.
Huh? Alrighty then. We're gonna actually go ahead and go back to our mystery mean problem. And we're going to talk about Mrs. Shields' class, or Mr. Shields. Who cares? We actually completed it. So let's go ahead and get in some more definitions. All right, so what is a confidence interval? So our definition is a C% confidence interval gives an interval of plausible values for a parameter. It's going to have the form. I'm going to just copy word for word because, sorry, the interval is calculated from the data and it's going to have the form. Point estimate plus or minus our margin. And we'll get into the other. You can look on your page 480 for the rest of it. Where it talks about margin of error, just laying down the groundwork. We've already talked about each of those things in our example, what the margin of error is, and talking about how we state that, right? That we can say at a level of whatever C% is, right? That the interval we create captures the true mean or the true population parameter, or whatever that is that we're doing. Okay. And that is expressly written on page 481, interpreting confidence intervals. And I'm going to just say exactly what it says there. You can read it too. So, to interpret a C% confidence interval for an unknown parameter, say we are C% confident that the interval from blank to blank captures the whatever your parameter is in context, right? The true mean of blah blah blah, or the true proportion of blah blah blah, and so on. And it's very important that you use exactly that language. If you don't use exactly that language, you'll get points taken. So you can't say there's a 95% chance that the true population parameter is in this interval. That would be really wrong. But that's not actually what's going on, right? You would have to say that it's actually not truly the probability. So we don't want to say that. Okay, moving right along. I think I have another example here, don't I? Yes, I do. All right. There's a large company concerned with many of its employees' in poor physical condition, which can result in decreased productivity. If you get sick a lot, you don't get work done. They want to know how many steps each employee takes per day. On average, the company provides a pedometer to 50 randomly selected employees to use for one 24-hour period. They're going to collect the data. They've got a company statistician. He says there's a 95% confidence interval of 4,547 steps to 8,473 steps. All right. What are you going to say? How would we interpret this confidence interval? Well, so let's say I'm going to write it exactly down. We are 95% confident. That being true. In this case, number of steps, right? Is. Cool. The book adds 4 employees at this company. I don't know if that's necessary or not. I think it's in context. We're talking about steps. Okay. What is the point estimate that was used to create this interval? It must have been X bar, right? 6,510 is right in the middle. And let's actually write how you calculated that by going 4, 5, 4, 7, It's 511. All right, and C, come on, we've been at C before this ends the lesson, so I don't want to have it hanging in the video. All right, recent guidelines, they say people should aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guideline on average? Yeah, because 10,000 is not in that interval, right?